Here are your geometry notes for section 1.2. Again, I'll remind you to pause the video where needed. Doing my best with the little glare that is in there. You'll have to work your way around that. There's no fixing it with a smartboard projector. A little more vocabulary. We're going to start out with some algebra, and then we're going to apply it to some actual geometry concepts. So you were supposed to have learned distance in algebra class, or maybe in any other class, also referred to as length mathematically. Just know those two words are interchangeable. How do we find the distance? It's the absolute value of the difference. The absolute value of the difference. If you remember absolute value, some of you remember it as the 2 bars, but rather than describing it as 2 bars, I would prefer that you describe it as the distance from 0. The absolute value measures distance. Of the difference, meaning the difference between 2 spaces. If you're going to find the distance, the difference from 2 to 7, you would subtract those two. And always taking the absolute value, because absolute value means that the answer will come out positive all the time. There's no such thing as a negative distance. If I hop in my car and I drive to Laval, it's 7 miles. If I turn around and drive back, it's still 7 miles. It's not negative 7 miles. So absolute value when you measure distance or length, so that you always have a positive answer. For example, go ahead and take the time to write this, draw it, and then pause the video and move on when you're ready. But notice this ST over here. S to T. Hold that thought.
Last call for buses. If we have any students out there who ride the bus, this is the last call for buses. Please hurry. Thank you.
I'm not sure if I can. Maybe I'll learn that later. So ST is a measurement from S to T. It's not a segment. Segment ST would have a segment bar over it. The measure from S to T is just written as capital ST. It'll always have an equal sign after it saying, oh, what is this going to equal? So if I want to measure the distance from S to T, or if I'm going to write a measurement from S to T, that's how I label it, from S to T, or it could be TS, because like I said, Laval to Reedsburg or Reedsburg to Laval, same thing. Do not put a bar over it. A segment bar means it's a segment, an object. Without a segment bar means it's a distance or a length. So if you were going to be asked to do some math with that, I don't say find PR, because then I'd be like, oh, there's P and there's R. Instead, as you mathematically read this, and we're going to learn and do well at the language of geometry and math, I would say this as find the measure of segment PR. I could say find the distance from P to R. I could say find the length of segment PR. But it's more than just find PR. Once somebody learns their geometry and knows it has gone past this point, they should know to call that the measure of segment PR. So draw this diagram. Okay, come back to me when you're ready. We want to know from P to R. We are going to go 5 plus 3. The measure of segment PR is 8. But I don't write 8. I write capital P, capital R, those are the 2 endpoints, equals 8. Now, if we were in class, I would call on you right now and say, what does that say? You would say the measure of segment PR is 8. The length of segment PR is 8. Something about the measure, the length, or the distance of segment PR equals 8. It's a lot more there than it seems. Over here, it says find the measure of segment JK. Go ahead and take the time to write that down. Just kidding. I'm serious, but JK, get it? Just kidding. A little bit different. You got to do the math here. The whole entire thing, JL minus 6. 13 minus 6 is 7. We know that that distance is 7, but we will write our final answer as the measure of segment JK equals 7. This is something that I still, let me get there, so that you can't see lines on my face. This is something that I still mark wrong on the final exam second semester. Legitimately, second semester, students are still mixing up, when do I put the segment bar on there? Or do I put the bar on or don't I put the bar on? In lesson 1.1, we put it on because we were talking about an object, an actual stick, a segment, a piece of a line. In lesson 1.2, now we're talking about a measurement, PRJK, the measure of those segments. And somebody might be thinking right now, like, wait a second though, how can I tell if it's the difference between a segment, a ray, or a line if you don't put a symbol over it? Somebody might think that this is a line, a segment, or a ray. Well, here's the trick. You can't measure a line and you can't measure a ray. Lines and rays are infinitely long. Rays go on forever in one direction, lines go on forever in both directions. So you couldn't actually tell me how long that line is. Only segments have a measurement. So we know exactly that those two are measures of PR and measures of segment JK. All right, moving on. If you're going to actually find the distance, yes, there is a distance formula that you learned last year that was like square root of parentheses x2 minus x1 parentheses squared plus parentheses y2 minus y, blah, blah, you get it. We're only finding the distance on a number line right now, so let's back it up a step. There's my number line. There's my 2 points, A and B, at -3 and 5. If I want to find the distance between those, and I go back to the description of distance, it's the absolute value of the difference. The absolute value of the difference of those two numbers. So your choice, whether you're driving from A to B, or walking, because you guys can't drive yet, walking from A to B or from B to A, you should get the same distance. If you choose to set up the problem as the absolute value of 5 minus 3, you will go from here to here. Minus a negative makes it positive. The absolute value of 8 is actually 8. Now again, I'm not going to answer it as 8. I'm going to answer it as the measure of segment AB equals 8, because that's what we're measuring, is this segment from A to B. Not wrong, just the opposite. You could say, I want to go, instead of from A to B, or B to A, I want to go from A to B. And you take -3 and you subtract 5. This is why we use the absolute value. -3 minus 5 is -8. You can't tell me it's a negative distance because you went from B to A instead of A to B. Absolute value makes it positive because it measures a distance. So now we say AB, the measure of segment AB equals 8 still. And I'm okay if you call it the distance from B to A. It's the same, whether you go B to A or A to B. No difference there. This is where we start to talk a little bit more specifically about geometry. Congruent might be a new word for you, congruent segments. We know what segments are now, but congruent. Congruent actually means segments that have the same length. Normally we would say they're equal. Not in geometry. They have equal lengths, they have equal measures. You could say 8 equals 8 or 10 equals 10, or their measurements are equal. But when you talk about an object, an actual segment, here, I'll give you a red segment and a blue segment. I've got a red segment and a blue segment. If I measure these segments, this one is 5 inches long and so is this one. They have equal length. But if I'm going to talk about the object itself, this pen, this segment, if I'm talking about the objects themselves, I would say this blue pen is congruent to this red pen. These segments are congruent. It's not the same as equal. It's a little different. You and your friend are both age 15, so you are equal in age. But if we were talking about, we're not talking about your age, we're talking about your congruency. Are you the same size? How do we represent that mathematically? If you're talking about their measure, they are equal. How do I know this is measure of a segment? Because it doesn't have a bar over it. Go back to my previous slide if you still don't make sense of that. The measure of segment AB equals the measure of segment AD. That's your comparing sizes. If you're comparing the actual object of segment AB, you put a segment bar over it. Segment AD is an object. It's an actual segment, not just their size. And this is what a congruent bar looks like. It's an equals with a fun little squiggle over the top of it. Work on that, practice it, make about 5 or 6 of these. It goes up, down, up, up, down, up, up, down, up, up, down, up, over the top of an equal sign. Maybe not the first couple times, but after that, I'm going to mark it wrong if you draw a congruent sign like this and you go, okay, mathematicians or anybody who's had geometry does not know what that is. Careful with the upside down congruent symbol. That's not right either. It's supposed to go up first and then down. So practice it. Try a few of those. Next up, nothing on this page. A postulate, another vocabulary word. You're going to see postulates. I know, you're in math class and you're getting more English vocabulary than you ever have. Get used to it. It's geometry. A postulate is any rule that is out there that we cannot make a formal mathematical proof about it. It's just true, and we know it's true. And for a good example, our first postulate is the segment addition postulate. Segment addition postulate, which basically says I'm going to take 2 segments or more, I'm going to add them together, and I know how big it's going to be. If B is between A and C, B is between A and C, and we know again that that's point B, point A, point C, then the measure of AB plus the measure of BC is going to equal the whole measure of AC. That's what the segment addition postulate says. Pause it and write that down, and then we'll get a little bit more in depth. First of all, another vocab, between. Between means it must be collinear. We learned collinear the other day, now we're applying it. Collinear, it has to be in a straight line. A, B, and C have to be in a perfectly straight line. Okay, you can't say that I have broccoli in between my teeth if I'm holding the broccoli out here and my teeth are back here. Between means it actually has to be right in between there. Okay, so if I have point A here and point C over here, point B is not between them. It's not between them unless you can make a perfectly straight line that goes through all 3. So, more specifics, but things you have to know. And with the segment addition postulate, you're going to need a diagram because then it makes just so much more sense than just trying to read this. You've got point A. Go ahead and draw this up by your segment addition postulate. You have point C, and you're going to put point B between them. Must be collinear. It doesn't have to be halfway. It doesn't have to be in the middle. It just has to be between. So if you want to put your B way over here by your A, okay, check your spacing, social distance. Maybe they shouldn't be so close. Okay, B is between A and C. If I want to make one full segment and I take AB and I add that to BC and I put them together, when I'm all done, I'm going to get from A all the way to C. Okay, we have something called common sense. I think common sense is another word for postulate. It makes sense that if I found 2 sticks in the yard and I measured this stick and I measured this stick and I put them together, it would make one big stick. And you would find its measurement. That's all the segment addition postulate is saying. Take one stick, put it with the other stick, put them together and measure it. They're going to equal it. Don't make it more complicated than it is. That's what it's asking. So for example, we have 2 examples and then you're done. Point Q is between point M and point W. Notice I say point even though it doesn't say point in there. Draw a sketch, then write the SAP. SAP? What? SAP? Segment addition postulate. Got it. Draw a sketch, then write the segment addition postulate. So I'm going to start just like I did before. Here's my point M. Here's my point W. Point Q is between them somewhere. It doesn't have to be in the middle. And then because we're talking segment addition postulate, go ahead and make it a full segment. Then write the segment addition postulate, the measure of segment MQ, we're measuring its segment, plus the measure of segment QW, when I put them together is going to equal MW altogether. Makes most sense to write it in that order. If you did it in reverse, WQ, QM, WM, it's not wrong, it's just weird that you would write it backwards. Pause it if you need to write all that out. Last one, draw a sketch. Use the segment addition postulate to solve for the variable. Then find the lengths. So you've got, we've got algebra mixed in with geometry, but some of you love algebra. You have the measure of segment LM, the measure of segment MN, and the measure of segment LN. If you answer this and you come up with it and you say, oh, well, y is going to be equal to this, it's wrong. I don't care what answer you come up with because the directions say draw a sketch. All right, start it. I'm going to make a black sketch with point L, and it looks like I used M twice, so M is going to be between, and it looks like N comes last. So I'm going to draw a sketch with capital L, capital M, capital N, all capitalized because that's how we label points. Then it says use the segment addition postulate to solve. I think maybe it would help if I filled in what I know. LM, the measure of segment LM is 7y plus 9. The measure of MN is 3y plus 4. And all together, if I went purple, red and blue make purple. This is art class too. All together, it's going to be 143 units. Use the segment addition postulate to solve for the variable. So you're going to take little segment plus next segment equals full segment. And that's going to look like an algebra problem. 7y plus 9 added to 3y plus 4 is going to equal 143. Set this up, pause it, and solve it. Pause it, get all the way to the end, tell me what y equals, see if you got it right, and then turn it back on because I'm going to, just try it on your own, refresh your skills. Pause. All right, we're back. Hopefully you combined like terms. The 7y and the 3y means you have 10 y's. The 9 and the 4 means that you have 13 altogether to make 143. If you subtract 13 from both sides, you end up with 10y equals 100. No, it doesn't. 10y equals 130. Good thing you did it on your own. Then you're going to divide by 10. And you're going to find out that y equals 13. And then you're going to be like, oh, I'm so proud of myself. I did it and I got the right answer. And you're going to circle that. And I'm going to say, wrong. You just did the algebra, but this is an algebra class. Go look. Use the segment addition postulate to solve for the variable. Got it. Comma, meaning continue on. Then find the lengths. Your final answers when you're done are LM equals 7 times 13 plus 9, which is, I don't know what that is. 7 times 13. I'm not supposed to do this. I'm supposed to use a calculator. Is 31. 31 plus 9 is 40. 91. 91 plus 9 is 100. See, we all make mistakes, and you shouldn't do math in your head, especially when you're on camera and in front of everybody. Then you plug in for MN, and you plug that in here. 3 times 13 is 39, and 39 plus 4 is 43. And then you make sure when you're done that the segment addition postulate works, and you get a total of 143 altogether. So if we add this up, those are your 2 final answers. Remember to do the geometry, not just the algebra. All right, that's lesson 1.2. Go ahead and do the assignment for that. Go back and check your notes for reference. Good luck.